On this next example, I want to show you something where I'm a little surprised about how the author of a textbook handled a particular problem when it is not necessary to go into what the author went into. I'm sorry that the scan didn't come out all that clear, but we have interest being compounded monthly, where you have an initial investment of $10,000 growing to $15,000 after 5 years. And we want to find out what interest rates would result in that. What the author shows is dividing both sides by 10,000. That's good. So monthly, we've got 12. We also know this is happening in 5 years. So 12 times 5 is going to be 60. He's solving for R in 1 plus R over 12 to the 60 equaling 1.5. So to get that 60 out of the exponent, he takes the natural log of both sides, which allows us on the left-hand side to bring that out in front as multiplication. And that just trades having R inside of an exponent to being inside of a natural log. So then he had to divide both sides by 60. And to get 1 plus R out of 12 out of a natural log, he had to raise e to that power on the left and e to this power on the right, so that we'd have 1 plus R over 12 equals this. Subtract 1 from both sides and multiply by 12. So I'm not sure what kind of rounding might have gone on there, but it looks like 11.81% by the end. Instead of doing that, what I'm going to do is take 1 plus R over 12 to the 60th power equaling 1.5, because the variable is inside of an expression where we know what number the exponent is equal to. I'm going to take the 60th roots of both sides, and that is the same as raising to the 1 over 60 power. All right, so 1 plus R over 12 equaling the 60th root of 1.5. Subtract the 1 from both sides. That would be the same as adding -1. -1 plus the 60th root of 1.5. And finally, to get the 12 out of the denominator, multiplying both sides by 12. So what I'm going to type into the calculator is 12 times the quantity -1 plus just the 1.5 raised to the 1 over 60 power, raising that 1.5 to the 1/60th. And let's see if we can get the same result of 11.81%. So here we go. And yes, there would be a way to type in a 60th root, but given that we know the connection of roots to, 1.5, we know the connection of roots to fractional exponents. We've got the plus sign. 12 times the entire quantity, -1 plus, insert that. And then it's the 1.5 to the power of 1 over 60. I'm going to need to put that fraction in parentheses. Close that set of parentheses, and then the overall set of parentheses. This should be approximately 0.1181, which would convert to 11.81%. I did not get the same answer, but zooming in, I can see that that was supposed to be 18,000 after 5 years. So that when we isolated this part by dividing by 10,000, that was a 1.8. So let me fix that. Replace the 1.5 with a 1.8 and see if I then get the answer that that author did. So here we go. All right. Hopefully the calculator is what is showing up. Double checking that. It looks like it is. Okay. So 1.8 instead of 1.5. Go. There we go. The 3 after the 1, that would round that down to 0.1181, so 11.81%. My error was not in my approach, but in the blurriness led me to misread 18,000 as 15,000. And that's all for now.